Okay, interactors, and the question is, how can they vary? Okay, so let me show you three user interfaces. Here's one, here's another, and here's the third one. And I'm showing you three different kind of user interfaces that could be implemented by different interactors. And can you give some terms to differentiate among these three classes? Can you put them in three different classes? So the first one you might call, I've actually used the term already in class today. So what am I doing? I'm entering a line, I'm seeing a display. Sorry? Command? Yeah. Command oriented, or Fred, were you going to say something? So what's a term? Yeah, that's an echoing user interface. So command-oriented user interface, the command line, you might call it console-based, transcript-based. There's a lot of these. Teletype-based. The teletypewriter used to be one in where you just keep typing one line after the other. Okay. So and this interface you might call what? Let's go and put the laser pointer. This interface you might call what? A non-command based. GUI. The term GUI is often used for that. Okay, if this is GUI, then what is this?
Not even sure. Yeah, I'm looking at.
Oh, you're not sure, even sure this is a different class, right? But people
I'm sure that's actually like showing the same.
No, it's not showing the same data.
It's not. Okay.
No, they're just three different interfaces.
Okay. I thought there were three interfaces for the
same object. Yeah, no, I
don't understand that.
I wanted to do that, but I didn't have enough imagination to create a graphics user interface for that. So we'll call this a graphics interface. Okay. In fact, these three interfaces are three different models. I deliberately did that to not confuse the issue. Okay. One is an IM model, one is just these widgets, one is the. Okay. So you might call this console-based UI, a GUI, and graphics. Okay. I can do graphics, I can do GUI, I can do console-based. Okay. That's the kind of stuff you might do. Is there a relationship between among these three? Is one a special case of the other? Is one, yeah. If you can do graphics, could you do a GUI? What's the difference between graphics and GUI anyway?
The GUI?
Sorry?
The GUI?
Yeah. They're both GUIs?
No.
If I can do graphics, can I do the GUIs? What's the difference?
You have generally a large library that helps you to generate a kind of a roughly standard set of imagery.
So somehow there's graphics here too. There's a slider there too, but somebody else did the graphics there. Here you did the graphics, right? So, and what is the console-based interface? It's one of these widgets that somebody else did. A text. It's a special kind of text widget. Okay, and the abstraction layers can be put in the following. Can be shown here. There's windows. Okay, where we'll see exactly what a window is. But there's a window abstraction. I kept using the word shared windows, and I was using the windows in a technical way. So you can create just windows, or you can, and so then you have a window-based or graphics interactor. Okay? Or you can put some layer above windows, which are special kinds of windows, which we'll call widgets. Okay? Text component, button, slider, and so forth. And now the applications you build are either Toolkit-based or GUI apps. Okay? Or you can say, I'm going to put a particular console text component on top of this. Okay? And on top of which, and then we have a console-based interactor. Okay? So there are three levels of abstraction here. And you also see that there's a little, why do you have three levels? There's a trade-off you have to often make between automation and flexibility when you design a system. Do you try to support a large range of applications? If you do that, you make very few decisions about the applications. So you're flexible, but because you made very few decisions, you automated very few things also. Okay? When you decide that I'm going to have sliders and buttons and so forth, you made some decisions about what the UI is going to look like. It's going to be a button, it's going to be a slider, and so forth. So you can provide more automation, but then you can't do arbitrary graphics. That's what this is called graphics. It should be called arbitrary graphics. And then with the console-based thing, you decided it's going to be all text-based. Okay? So what you see in my class notes is how to build a console-based UI, okay, with the model interactive technology. And what you have to do in your assignment is build a GUI with the same architecture. Okay, that may or may not be easy. And if it's not easy for you, to present just at some high level some conceptual differences between the two kinds of interactors and how do you interactors so that you can make your transition to the GUI interactor easier in your assignment. Okay, so that we'll see next time. Any last minute questions? Okay. Okay, good. So what we did last time was look at, so you have to build interactors. You have to build, you have to build GUIs. Okay, and I've told you to build GUIs as interactor model compositions. You're welcome to break up an interactor into a model and view, into a view and controller, but I'm not requiring that, okay, because often these two components are very tightly coupled. And again, I'm motivating things not from an abstract software engineering point of view, but from a collaboration point of view. And from a collaboration point of view, you separate the interactor, you separate the user interface from the model. That's sufficient. That means you can create multiple user interfaces on different computers that have different state. Okay, that's the necessary condition. Okay, so so we said, okay, we are going to have to build models and interactors. We saw that there was a division of labor between those two. And we were then going to look in some depth at various kinds of interactors, and then at some depth at various kinds of models. Okay? That's to help you do your assignment, of course. Also, it'll provide me with a theory that I can use later to go and figure out how to build collaboration abstractions. Okay, so collaboration abstractions tend to be built on top of single-user abstractions, and they might go and be tied to a certain kind of interactor, certain kind of and a certain kind of model. Okay, and so if I classify them right now, then I have a vocabulary to talk about various kinds of collaboration abstractions later. Okay, so that's the reason why I'm going in some depth. Okay, so we saw that the interactors are going to be is the green code you'll write, and the green code you'll write is a function of what it is based on. Okay, so you're not going to use the hardware directly. You're going to use some software system that gives you access to the input and output. Okay, and the lowest layer that you can get in today's computers is the window layer. Okay, and we'll see exactly what that means, but you have an intuitive idea what that means based on just the wording window and how you used your computer. And on top of that is another layer, which is the widget or toolkit layer. Okay, so a toolkit layer is a toolkit is a system that is composed of a bunch of widgets that are built on top of Windows. Okay, and one of these widgets might be a text component, and text component is what you use when you do print lines and scanfs, or in Java it's called, well, it's still print line at least for output, and they go and provide an abstraction above a text widget, which prints out console messages and scans console input for you and provides that in calls as data to the okay. And as I hint here, the lower the abstraction you use, the more code you have to write. Not necessarily true, but intuitively, you're doing more work if you're using a lower level abstraction. Maybe you're doing the work of a text widget when you go and create a window-based interactor. Okay, so that's something when there's all kinds of systems, and often systems design gets involved in religious wars, and based on basically many factors. One of them is flexibility versus automation. Okay, so you're going to be lower level and provide lots of flexibility, so you can build a range of applications, or you're going to make some decisions for the programmer and then automate them, and then the user of that, then the programmer is bound to your decisions. Okay, and Let's go on then. That's what we talked about last time. The picture is that we've got a model, we've got an interactor or an editor, which could be broken up into viewer and controller, as I said. And it's going to be using some helper objects provided by some system layer. Okay? It can also provide other helper objects it can also use helper objects defined by the programmer, okay? But it'll be using some helper objects provided by the system. Okay? And the question is, what is the interaction with these helper objects depending on the abstraction layer? Okay? So Windows, how would you, based on your knowledge of the English word window or the computer science word window and your experience with these, how might you define a window? A computer window, obviously. As a box screen, okay? And so if I have a text widget, which is built on top of a window, that's also a 2D box, right? So say something more.
It has certain panes.
It can have components, okay? So certain widgets can also have, like a tree widget, can have certain, or a more like a spreadsheet widget can have components too. Okay, but that's good. It can be hierarchical, but so can widgets. Okay, so we don't know what widgets are till we know what windows are, but like text widget is, and text widget is indeed just one rectangle, but you can imagine other widgets like a slider, which has a rectangle within which you can have another rectangle, which is a slider. Okay. So yeah.
I guess in terms of hierarchical structure, windows appear like immediately on the desktop and not encapsulated in anything else.
Okay, so there are top-level windows and sub-windows. Okay, and in a window system, so there's a hierarchy in both window systems and widgets, and the top-level windows are special. Okay, but those we'll call top-level windows.
What kind of application uses sub-windows these days?
Depends on the window system you built on top of. For instance, the X window system. So all the text box, text slider is also a window underneath. It's implemented as a window. So they're all windows. Okay. So text box is a window, a slider is a window. All of these things are windows. Okay. Now, depending on the toolkit, if you're AWT, you will use operating system windows. If you're Swing, you'll create your own windows on top of operating system. Okay? So whether the window is provided by the operating system or by the language, that's orthogonal here. Okay? So when you say rectangular areas, you're talking of sort of output, right? What about input? What kind of input do Windows provide? And then we can talk about exactly what API they provide for output. So rectangular areas, widget and window are both rectangular areas. Okay?
So you can have like buttons, various things that the user can interact with.
Okay, so button, so a mouse button. Okay, so left mouse, right mouse, middle mouse button, depending on which operating system you're on. And maybe what other kind of input might you provide? Or did you mean buttons on the screen?
I have buttons on the screen.
That's widget.
Okay.
That's just a window with, so a window with some application-specific behavior is a widget. Okay. So now that you know that there's application-specific behavior, what's a common thing? So I kind of hinted, mouse down, mouse up, left mouse down, left mouse up, middle mouse, right mouse. What else might you provide as a basic functionality? Keystroke. Okay. And if that's your input, what might your output be? So what kind of calls a window system might provide to display things on the screen? Set text is not one of them. That's very high level. That's widget. So what's the lowest level you can think of in terms of?
Just close the window.
So closing window, that's not quite output. That's something that the window manager deals with when you talk of top-level windows. Okay, which? Sorry? That's the input, and then what happens? So it can make sounds, okay? It can make sounds, but we talked of visual areas, rectangular areas. So how might you display something? What kind of calls might you provide to display something on a window? Pixels. So you might say draw a pixel here, draw a bit here, draw a bit here. A little higher level than that. So you can provide a mixed pix map. But if you want to draw a character, do you really want to provide a fixed map? So the reverse of keystroke is print a key perhaps, or print a string, or draw a circle. Okay, draw a rectangle. Draw a rectangle, draw a string, draw a circle. That's enough to now build all your other widgets. Okay, so I guess I should have provided this context. The UIs I showed you earlier. I showed you a UI with a console-based interface. I showed you UI with widgets, and I showed you a UI with a character encircled with a caret. And that was what a Windows system was needed for directly. So let's go and see. Windows are untyped. When I say untyped, means these are just rectangular areas that are not with which you haven't added more semantics. Whether that rectangular area is displaying a string as a text box, or as a button that you can press, or a menu, that's higher level layer. Okay, in all cases we have a rectangular area on the screen. Okay, and input, the basic input is what the hardware provides essentially. Okay, the hardware will tell you that a key got pressed, a key got released. Okay, and the software then can say, oh, this key got clicked. Okay, and similarly mouse buttons. Okay, so you can say if the user presses A, the Windows system, forget the widget system, is going to tell its client the key A was pressed, okay, and it might also it'll tell you which window it was pressed in. Okay, that's why it's good to have different areas, because the program can say, okay, did it come from this window or that window? It doesn't have to go and take a big window and divide that into smaller areas and figure out in which area the user pressed. Okay, so hierarchical windows are useful even at this level of abstraction. Okay. It might also tell you the X Windows system, which is what I know really well compared to the Microsoft Windows system, would also tell you what the mouse position was at that point. So it'll give you the X and Y coordinates. In Java, and I assume in the underlying Windows operating systems also, you have to go and track the mouse position separately. Okay, but in X, you got it together. So it might or it might not provide you. Okay, and the output basically are drawing operations. So this is why Windows systems are good for graphics applications, okay, where you have to do some custom graphics. And you can say draw character A in window, and then give an XY coordinate relative to that Windows origin, which is the upper left quadrant. Okay, so that is why, again, it's good to have hierarchical windows at the very base level to ease the programmer's task, okay, of figuring out which area you're in. Okay, so that's basically the window abstraction. And has anybody used this level of abstraction to build a GUI? Build a user interface? You guys did in 401 when you were drawing your avatars. Okay, you were essentially drawing things using this abstraction, and you were getting mouse events and text events. Okay, so that's the lowest level. People tend to not use it very much, okay, because it's hard. So here's the example. Okay, and what I've done here is what happens in this example, which is not very interesting, but just because I needed an example with some functionality. It draws the last character at the last position at which the mouse was clicked, and along with the character, it displays. I should really use my laser pointer. At the last, it also draws a caret and a circle around it. Okay, so just to show you the various kinds of draw capabilities you might. And here's some code to illustrate what a window client might look like. And this JFrame is a window. Okay, JFrame is also a top-level window, but you can have sub-windows too. We just have one window there, and it doesn't have any behavior. Its contents are not associated with any predefined behavior. It's just a rectangular area, okay, which you can use for various reasons. And what I've done here is here's some output code. Okay, so it says draw an oval, draw a line, draw a string, And in all of these cases, you need an x and y coordinate, and you also need some width and height coordinate for the overland line. Okay, or actually it is a second. Sorry, you have a width and height for the oval, and you have x1, y1, and x2, y2 for the line. Okay, but that's just details. So we have output calls, and input is being received here. Okay, so again, the abstraction is a key event occurred or a mouse event occurred, and that would mean you know whether it was clicked or it was pressed or it was released. So you know that level of detail. Okay, and you can get the exact character that was typed, or you can get the coordinates of the mouse position. Okay, and the interesting thing here is that we talked of the observer pattern, and the way you're receiving input is through the observer pattern. Okay, so you register yourself as a client. You register yourself as an observer of the window system, and whenever the window system detects something interesting, it calls this method in your program. Okay, and if I was to call this method a callback, does that make sense to you? If I would say key type is a callback, how many of you have heard the term callback? So what's the difference between a callback and a call? Nick?
A callback is generally a method that that is designed to be called when an event occurs. Where Java doesn't have really good reflection, but in a language, for example, you can pass a pointer to a callback function as a parameter in a function call, so that the callback function you specify will be called at a later point in time.
Okay, so callback seems to be that, if I go and make you a phone call and I leave you a phone number, then you call me back, right? So that's sort of the intuition, right? And so you make a call to somebody and say, when you have something interesting, call me back on this, okay? So that seems to be, you're saying it's basically like the observer pattern almost, that any observer notification method is a callback. Do you have a different definition?
No.
So that's a very general definition. I'm going to give you more of a systems definition that is more traditional. So we are talking of client layers, and we are talking of system layers. Okay? So we're talking of a system layer being at a lower level, and a client layer being at a higher level. Okay? Higher level layers make calls to lower level layers. Okay? The lower level layers are visible to the higher level layers. Okay? When you build a layered system, the question often is, can the lower level layer call back the upper level layer? And that doesn't make sense, because it seems as if it would have to know the API of the upper level layer. If it knows the API of the upper level layer, then how is that layer upper level? So what happens is the upper level layer says, you don't know what this procedure does. It's my procedure. Okay? But I know about this particular event that you handle. And whenever that event occurs, please call this procedure. And like I said, there's no knowledge of that procedure. And if that procedure happens to go into a loop or does something really bad, then you can really corrupt the low level layer. Okay, so they're dangerous, these callbacks. Okay, so that's the traditional approach, the thing that, and callbacks are ways for the lower level layer to call upper level layer, and that's exactly what's happening here. That the lower level layer is calling key type in the client layer. Okay? And the alternative in the X window system was for the higher level layer to actually look at a queue of events and read that event and block till the next event occurred, and then process that event. And that was tedious programming. You had to devote a separate thread for doing it. What happens in Java and these systems is that there's an AWT thread that will automatically invoke these callbacks in the upper level layer, so that the upper level layers don't have to go and create their own thread and write this little event. Okay. So and this is how it's done in 1.1 and later. In 1.0, the way you got events from a system layer, and you'd probably laugh at this, but this is how Smalltalk did it in 80s, and this is what the guys in Java blindly copied, that you would make your software a subclass of the system software. And you would override a method in the upper level layer and say, super, do your work, and then you did your work later. Okay? and that has all kinds of software engineering issues. That would mean that a client is so a button client is a button, which is not true. Okay, but here the button client can be in a separate class. There the button client was a subclass of a button, and when the button was pressed, it would just invoke a method in its own code, and you would override that method to get that event. Okay, so that's how it's done here. Yeah.
Speaking of versions of Java, is there a specific version of Java you want us to use for this? Like
So,
Java 8 be supported?
8 is compatible with the lower level versions, right? So go ahead and use 8, go ahead and use 7, go ahead and use 6 if you want to. Most of this code is version independent. I use 7 because that was the last version I downloaded, and it works. But that was a question on Piazza that I answered. Okay, other questions? So notification method called by lower level abstraction is a callback. Okay. Nick's definition is more general. It says you can have different levels of abstraction and a method is called back. You can use both definitions, but this is the traditional definition. Okay, this is more restrictive. So in this particular class, I have created a subclass of JFrame called a circle character drawer. Okay, and it is defining the callbacks that superclass is basically invoking. Okay, and you can have separate classes. That is what 1.1 allows. And so somewhere here it registered itself as a listener for those events. Okay, and what I've done is I also have methods like setChar here to be called by external other client, other code, other applications. Okay, so that setChar is essentially providing a reusable functionality. Okay, so somebody else can use this particular class to go and just set the character, and that character will change on the display. Okay, this is like having a set text in a widget. So what I've really done, shown you in this screen, is what a window is and what a widget is. I've taken the window layer and used that to define a widget called a circle character drawer that has an API that somebody else can use. Somebody else who doesn't want to draw the circle, doesn't want to go and draw the caret, but all they want to do is change the particular character that's displayed, and this will go and display the character. Okay? So you're seeing both layers right here. Okay, so widget is window plus some reusable functionality. So that's this now is a picture about that. So widget is built on top of a window. So you have a widget and a widget client, and widgets are basically typed windows. So they're also rectangular areas, but like I said, they're windows associated with some higher level behavior, with some behavior. Okay, and the callbacks, again, we have input callbacks, and what are they? Anything, whatever some widget programmer dreamed of. Okay, so the toolkits are much more difficult to explain in an academic fashion. Okay, there is no, it's whatever the programmer did. Windows systems have a very well-defined behavior. They're easier to make collaborative. Widget systems are harder to make collaborative because there's no common thread going through all of them, okay, except that they're built on top of a Windows system. Okay, so user enters a line of text. You might get some text entered callback invoked there, or it could be button pressed, whatever, soft button pressed, and output and other calls are widget specific. So you can do get text to see what the current text is, and then you can change the text to update the text. Okay, so okay, questions? And a toolkit is a set of widgets essentially. Okay, so when I told you guys, oh, use Google to figure out what you want to do, I said use Google to figure out what widgets exist and what the exact API is. There's no real fundamental concepts that I can present in class to explain those. Okay. And there's lots of sets of widgets. People have agreed pretty much on what a Windows system should look like, though there's Windows systems of various kinds. But the widgets at the widget level, there's more variety. So even in Java, there's AWT, Swing, and do you guys know of any other toolkits in Java? Google has its own, GWT. IBM has its own, the Eclipse environment that you guys use. It's got its own Windows system, and anybody know what its name is? SWT, Simple Window. Oh, I think it's called Simple Window. Okay. So, and widget use example. So here's a JText field, okay, that's provided by Swing. You say this, and you associate a listener with it, so nothing complicated. And the listener here has this method that's called whenever you hit enter. And when you hit enter, you can go and figure out what the current text was by doing a get text call. And this is just like I said, a level of detail. Okay, so you get notification of new line entered, and in your project you have to get information about not only the complete line but about each character that's typed in also. Okay, so when you do the topic, especially when you go and send the topic to other users, each character will have to be sent. Okay, we are not sending the whole topic line. The message line, we send the whole message line. But even in the message line, if you go and do the status computation, whenever a character is typed, you need to know what's happening. Okay, so this particular method allows you to go and action perform lets you get the full line. And if you add yourself as a document listener of JText field, then you can get the incremental changes also. Okay, and JText field has that, but text field hasn't. That's why I've put all those constraints in your assignment, that please use this kind of text widget for this particular component. Okay. Okay, so you guys, one of the concepts that came into your head when we talked about Windows systems was the hierarchy. Okay, and here we just use an atomic window, and here we're using a composite window and widget system. So we looked at a particular window, JText field, okay, which is embedded, which is also a widget, which is embedded in a bigger object. Okay, so that means there's a hierarchy, and in fact, this is also a JFrame at the top level, and within JFrame is embedded or is a child called JText of type JText field, and root window component is a special window. Okay, so in this hierarchy, all of the windows are equal. Well, a parent window can have children. Okay, can have leaves, and leaf level window can't have children. So there's that difference. But all the parent windows are similar, except, or all the container windows are similar, except for the top level window, which is special. And that is what Nick was hinting at, that the top level window has some special behavior. It has a border around it. Okay, and that border allows you to go and manipulate it. You can go and iconify it. You can go and resize it. You can move it. You can't do that to the children windows. Okay, and these operations are handled by not the window system, not the window client, but a separate piece of code called the window manager. Okay, and that window manager can also be customizable. So in the same system, you can have different window managers. Okay, so you're creating a tree. And so that's the basic concept. You guys have done 410, so building a tree is not no challenge. But one of the differences between the tree you create for a UI and a tree you create in the competition code is that tree is displayed. Okay, and the same tree can be displayed in different ways. So you associate a tree with a layout. Okay, and in your project you'll be basically doing a grid layout where you'll be drawing rows and columns. And in my implementation, I just had rows. I didn't have any columns. So there's a particular layout manager you can use, and you can use this particular one that I mentioned to create the layout. And other than that, so you have parent nodes. You have, within that, each node can say how its subchildren are laid out. You have children nodes like text field. And you have link creation. You say add this child to this parent. No big deal. Okay. In this code and in Java toolkits, the AWT and Swing toolkits, you create the children and parents separately, and then you can put a child in any parent, and you can reparent a child, and so there's a lot of flexibility. But if you ever use some more restrictive systems like SWT, when you create the child, you specify the parent, so it belongs to a particular parent, and you can't reparent it. Okay, and that's easier to implement. It may be a little less flexible when you code. Okay, and once you create a tree, you have to go and size the top level window. Okay, don't forget to do that. and you have to make it visible. Okay, by default, it's not visible. And can you guys see why you don't just make it visible the moment the trees create? As the trees, when the top level window is just created, why not make it visible?
Because when we create it, we haven't finished setting its state.
And
if
so
we make it immediately visible, that's going to be ugly and waste a lot of resources rendering something that's not ready yet.
Okay, so this is a general concept in computer science. You create a bunch of threads, then you start them. Okay, after all of them have been created. So if one thread refers to another thread and depends on another thread, that's created in the system, and then you make them ready. Okay, you create a bunch of windows that are going to together provide some functionality, and you make them visible later. Okay, so that's a general principle. Okay, so you can have different kinds of helper UI abstractions associated with an interactor. And at the console level, what the interactor is doing is passing input and unpassing output. Okay, that's what you guys have done in your non-GUI interfaces, user UIs. And in the widget level, you're creating widgets, and here you're drawing shapes and processing key events. Okay, and you can always define additional programmer-defined objects. Okay, so what I'm saying is that when you build an interactor, you have an interactor object. You have all these objects that you're using. Plus, of course, you're welcome to have other objects. Okay, and just as an interactor can use different kinds of UI objects, the same UI object can be used by different interactors. Okay, so system out and system in, as my next slide shows, can be bound to two different kinds of interactors. The same object, in fact, the same system.in and system.out can be bound to either this interactor or that interactor. And I mentioned this because some of you are a little confused by my demos. So I can demo the application using Eclipse, and so I use an Eclipse text widget to show the input and output. Or I can demo it using a widget that I built myself, okay, which is using the same program. Okay, it just is a convenient way for me to demo my programs. Okay, so this is not a separate program, special GUI program. It's just a regular program that I bound to my console window. Okay, because some of you asked me this question, that what's the difference between this UI and that UI? Interactors can be structured, so interactor can have children interactors. Okay, just as windows can be structured, so can interactors, so don't feel confined. If you don't structure them, that's okay also. And this happens when you compose user interfaces. So you might take this user interface and embed that in another user interface, so you have embedded interactors. Okay, and you kind of see that in our project. And I'll elaborate on that in the next slide deck. So you have window, widget, and console layers. We talked about the different calls and callbacks. We define windows, okay? Then we said windows, widgets are basically windows with some extra behavior. And then console is just a text widget with some extra behavior. So you see the abstraction levels here. And you can have window and widget hierarchies. And that's something that you all came up with yourself based on what you've seen. And you have separation between interactor and the abstraction objects, and you can use that abstraction in useful ways. Okay, questions? I did escape, and I'm afraid. So we are going to go away from the model interactor pattern.